writing on
ladies and gentlemen, an anomaly in your data is not a flaw in your experimental setup. So we're just talking about the numbers that you collected. So when you're looking at anomalies in your data, things that were unexpected or off, you're not talking about the experimental setup or anything about like the physical part of what happened. Okay? You're talking about, you're looking at the 9 sets of numbers that you got. And you're looking at, okay, this doesn't look like it would fit here. Okay, that's what you're looking at. So you're kind of pretending your eyes are like magnifying glasses. You're really zooming in on your data and looking at it in detail. Thank you to those of you who are respecting others' need for silence as they're analyzing the data. Disregard that alarm. Okay, I'm just going to continue stamping. Oh, you're saying this one? Do you think that's really far off?
Not that.
Because it's 1.0.9, it's a difference of 0.05, right? But why did you choose that number?
Because most of the bees calculate the 1 and then make their 1.086 and 1.09.
But if I compared this number and this number, I would say it's not that much far off. Okay, but that is true. Anomalies are not that you fix. You just, whatever data you collect, that's what you work with. You don't fix the data. Ladies and gentlemen, you don't have to raise your hand. I'll come around to you when I'm ready. Okay? And please be mindful, remember, of conversations that are taking place elsewhere. Okay, so you guys would all have to do the same one. It's completely far out, just because it's a different number. Yeah, I see. Oh, can we look at that? Can we look at that data? So turn over to page 1. Which one are you talking about?
Oh, we did it already.
Oh, okay. So if there's something that you redid, you don't have to talk about that. We're just going to be looking at this data, like whatever you have. Ladies and gentlemen, look up, please. Okay. Again, I'm going to explain what we're talking about. When we analyze data, for example, there are many things that we can consider, okay? But when we talk about, whether any anomalies in your data, we're not, like I said, talking about what happened during the experiment. We can talk about that later in other parts of the analysis, but in this question, I'm asking, in the actual numbers that you collected, were there anyone that was like really off, like this one, for example, right? If you had a series of these kind of numbers, 1 point something, 1 point whatever, or even if I had something like this, what if I had 0.98? Would you identify that as an anomaly? not that far off from 1.1, right? But this one is very far off. So that's the one that I would probably have to explain. Okay. Let's see. Stephanie, what did you notice? Everyone, you can turn to page 112 right now. Okay. And that's where you had recorded your data. What did you notice, Stephanie, about, did you notice any trends or patterns?
As the height with the velocity got larger,
As the height increased, what happened?
the speed increased.
The maximum velocity increased, the average, okay? Actually, can you give me your average for height 1?
5 centimeters.
I know, your average, I know your height 1 was 5, but your average maximum velocity.
0.737.
0.737 meters per second. And then for height 2, it was
0.862 meters per second.
0.862. Okay. And then for height 3,
0.954.
0.954. Okay. So when you look at this, yeah, you can tell that, we said this was about 5 centimeters. Your second one was about what? 8. So this was 5 centimeters. This was 8 centimeters, and the last one was
13 centimeters.
13? Okay, so 13. Okay, so as height is increasing, the height of the ramp is increasing, their velocity of the car is increasing as well. Everyone look at your data and raise your hand if that is not the case for you. Raise your hand if you have something like, 0.737, and then this is like 0.53 something lower, and then it goes up. Everyone look at your numbers and see, do any of you have something that is not increasing from height 1 to height 3? Because it does happen, and it has happened. Yesterday, one of the groups in this period, they had data like that. But does that mean they should ignore that? Okay, no. They just have to be able to explain what happened there. Okay. Let's go ahead. All right. I didn't really explain friction very well yesterday, so I wanted to explain it again using my chair. All right. So, friction, everyone, is a force. Friction is a force that opposes the direction of movement. It is opposite the direction of movement. So, Kiana, I'm going to drop her off on her seat. Okay, so, could you please read that for me? Yeah, please. So, the direction of movement is which way? Fine. Direction of movement is this way, yes? But how come she stopped? How come she stopped? Sidra, why did she stop? Did Christian come up and stop the not the car, what is this? The chair? No, he didn't. So why did this chair stop? Pablo? Yeah, friction. Okay? Because this is the direction of movement, and there is a force in the opposite direction that is opposing the movement. Okay? So there's actually two areas. Okay, there's two areas where you see friction evident here. Where is one area where you see friction, Jonathan? Between the wheels and the floor. Okay? This is not ice. If it was ice, it would be less friction. Yes?
Kiana and the chair.
Kiana, well, that's true. But in terms of the movement of the whole system. So, what's hitting her right now? It's
air.
Okay, air. Sorry. Kiana's like, I'm not in the mood for this right now. Okay, so air is hitting her, okay, and the wheel and the floor, it's kind of like rubbing against, right? Does anyone know what that is called? I know we haven't learned it yet, but as air is hitting her, oh, I know. It I'm not sure if I gave this example yesterday, but you know, you get in trouble, so don't do it. Your parents are driving, and they get on the freeway, and you roll down the window, and you stick your hand out. What happens to your hand?
Yeah, I do that.
Your hand goes woo backwards, right?
Yeah, I'm like, I could
And it doesn't move.
Oh, very good, Bob. Okay. You know what he just said? He said when he moves, he puts his hand like this, it goes wham, like this. But then when he goes like this, I bet you if you do like this, same thing. Okay? It doesn't move as much. Who thinks they can say why? Who thinks, Jade?
It's more aerodynamic.
This is more aerodynamic. Can you explain what you mean by
It's more
that?
like pointy.
It's pointy. So, by the way, before we get to what you just said, when we are doing this, what is pushing it? Air. Doesn't air have molecules? Yeah. All those at the speed that your car is going, it's like hitting against it, all of them. And so it's going woo back. But when Bob goes like this, then it doesn't move as much. And JJ said it's because it's more aerodynamic. What do you mean? What is the difference in terms of like the air hitting, going like this, or the hand like this?
It catches less air. Like that.
It catches less of the air. Okay. So yes.
Like you said, the airplane, when they're trying to brake, they kind of open like those fins, whatever, on the sides.
Fins, like on the wings. Yeah. Have you guys seen that? Like
Yeah.
and then I've noticed that these flaps come out. There's like 3 of them. And so, oh, you can. I'll drop you off. Okay. So who can tell us? No, I'm not gonna ask. How the class dojo? Yay! All right. Unfreeze this thing. But why am I asking that question? Think about how does that affect, how does it relate to what we did with our car? Where do you see the friction force? Where do you see friction in our experiment with the car? Where do you see friction in our experiment with the car? Okay, that's the question. So where are 2 areas you saw friction happening with the car, okay, in your experiment? I'm going to give you, you can talk about it with the people at your table. I'll give you 49 seconds to talk about it, okay? Ready to go. 2 areas where you saw friction.
and the wheels in the ground.
The wheels and the ground, like the track, and the top of the car with the wing.
The index card.
Yeah.
The index card, and then where's the other one?
Wheels and the ground.
Okay. What could you have done with the index card to reduce air resistance?
Do it like that.
Okay, but what was the purpose of the index card?
So the motion detector could.
Yeah.
Wait,
So if you have it just like this, it might be difficult, right? So you could do something a little bit different. Maybe.
It's cool.
Keep talking. Okay, I'm gonna.
Out of what's in it? Have a meal.
All right.
Do you know what that is?
Bobsicles. Okay. So, where are 2 areas where you saw friction in your car?
The car and the track,
The car's wheels and the track, okay?
and the air with the index card.
The air with the index card. By the way, that kind of friction is called air resistance, okay? The air is resisting the movement of the object, okay? So, I throw a ball, and there's air resistance, so eventually it's going to, the air is resisting the movement of this ball, so eventually it's going to slow down, okay? But without air resistance, it would just keep on going, and without friction. Okay, so what could you have done differently with the card? He said, you have this big old card with this car here, with the car and the index card, and it's going, and you have all that air hitting against the card. So what could you have What could you have done with the card?
Get the card and put it instant bent it.
Okay, you could have bent it. Okay. One person in sixth period, actually on the first day of the experiment, she folded it like, I know, I was like really impressed that she did that. And I was like, why did you do it that way? And she had a reason. And so she folded it like a cube, like a box. Anyway, and like this. But everybody else just had it flapping like this, you know? But I was hoping that somebody would realize, oh, wait a minute, something's not cool. So she did it like this, okay? But what would have been even better? Okay, this is the car. This is the car. She had it like this. What would have been even better?
And she put it that way, down, right?
Maybe this way. Huh? What was that?
It's like laying on it.
Like this?
Yeah.
But what was the purpose of the index card in the first place?
For the
For the motion detector to detect it, right? Detect it. So maybe she could have, or you guys could have folded it in such a way that the detector could still detect it, but it doesn't have so much surface area to like hit against all the air molecules. Okay? Alright? So, alright, right now I'm gonna set you loose. It's only one group that's going to be finishing the data collection, and everybody else, I'll be walking around to help you with your analysis questions. So you'll be working on number 4, which is, this is where you have to do a lot of thinking. So please circle it, number 4. And if you come up with, yeah, I mean, there are a lot of flaws, if you think about it, a lot of flaws with this experimental setup, you know. And so this was the experiment that came with the vernier, okay? So if you were to redo it, redesign it so that you can get more accurate results, which is what I ask you in number 4 of the conclusion, then you can redo your experiment. We will probably do that. Redo our experiment with your experimental setup, okay? So you guys can go get set up over there. Oh yeah, please get with the group that you collect the data with. You can pull up a chair like that. Okay. Thank you. Yeah, all the way. More. More?
It should have been a triangle.
That's how instruments are being played. Anyway, what are some of the factors that affect the data collection, i.e.
It should have been a cube. It should be experimental.
It's not graphic, right?
Improve this to make it more.
Triangle.
Okay, what were some flaws that you guys noticed?
The index card.
The index card, because when the air was pushing on the index card, it made it go back, and also the graph
slowed it
is
down.
Okay, there were two things. What happened?
when the air was pushing on the index card, Ishrak said that it went back, so it made the graph look like if the car went back.
Oh, okay.
Back.
So what can we do? Okay, so sorry. So that was that. And what was the other issue?
I think it also made the car slower, maybe.
Okay, that's what we just talked about, right? The air resistance.
Oh, another thing was that I noticed that even if there was like 3 books stacked, the ramp, a lot of the ramp was like the slope was like really steep at the beginning and then just like flat with the floor.
Oh yeah.
So maybe make it more gradual to make it faster.
Oh, the entire ramp. Oh.
Because if you put like, even if it's like 3 books, the ramp is pretty long.
Yeah.
And so it's like at the beginning it's really steep, but at the end it's like flat with the floor.
But you don't think the initial steepness of the slope of that would affect the rest? even though, because I know what you're talking about, whether you're starting here, it's going to flatten out like this, or whether you're starting here, it's steep, but then eventually it's pretty much the same. But don't you think that drop would have some impact on the velocity of the car? You know?
Yeah.
But you can try that to kind of, so you're saying you should have those blue things underneath? Yeah, you can, that would, if I were you, yeah, I would definitely try that. Okay, so that's something that you would write on number 4 of this one. Okay, so those are some flaws. Let me see, what else? Okay, can you think of any other flaws? We can come back. I'll come back to you. Okay. So what were some flaws that you guys noticed in this experiment?
That the index card was being, like, air was pushing into the index card and making it slow down.
Okay. Anything else? How about the placement of the motion detector? Because I noticed some groups, instead of putting it upright like everybody else, they put it in a different way. And I was like, why are you guys doing that? How do you think they did it?
Maybe they put it sideways.
Why would they put it sideways like that?
Because, like, if it's standing up, it's going to be harder for them. Like, while the card is moving down, it's not going to be detected.
Yeah. So, you know how everybody had like the stack of books, and then they had the motion detector up like this, right up against the ramp. So one group, they did it like this. And I didn't say you couldn't do that, right? So we'd have to look at their graphs to see if that was actually effectual, like effective. But that was one idea that they had, which is good. So if you were to redo your experiment, which we might, you might want to think about, would that be something that you would do?
For number 1, do we have to just show our work?
You don't have to show everything, just
The setup?
just the setup, yeah. Yeah, because I mean, I know you all know how to calculate averages.
You said it was a cube they made, right?
The girl made it like a balloon, but I'm not saying that was the best design. But just make sure. Oh, I was gonna ask you, what would you do differently? What would you do differently with the card to prevent it from flapping, to prevent it from slowing down?
Make it more stiff.
Make it more stiff? How would you do that?
On my card.
So that's one reason why I asked people, how many cards do you want? Because some groups, they taped the 2 cards together, and they asked for more tape. So yeah, that could be a possible way to go around it being flapping back and forth like that. But how about the slowing down business? That's something.
Redesign the triangle.
Into a triangle with one of the pointy ends facing the motion detector.
No, the pointy end is facing the
front.
way.
Isn't the oh that's right, is the front. Right.
And the back part is facing the...
Okay. But just want to make sure that it can detect it. So, but then I'm sure you can.
Do it like this.
Okay. Any flaws that you guys came up with?
The index card would make the card slower, but also the person who held the car back on the ramp might have pushed the car forward, increasing its velocity.
Oh, okay. So you had the vernier and you're like ready, set, go, and this person might have like pushed it?
Yeah.
Okay. So what can you do? So how was the setup? So they just kind of held the car, and then what did they do? Like let go?
I think they held the car on top.
Hold the car and then just let it go.
They held the car right on top and then they let go? Okay. What could you do to prevent like human error like that? Because yeah, what if I had Monster in the morning and I was like, you know, and my fingers are jittery, and that could affect your data. So what could you do to remove that factor? What could you do?
Something like on the ramp and take it away and the car would just roll.
Yeah. What is that thing that you could, because you can actually, I think I'm going to have you guys redesign it and actually do it. So what would you do as that lever thing? What would you do?
Maybe like a pencil.
Maybe a pencil? Yeah. And I noticed some groups doing that. They got a ruler. So the person, let's say it was Stephanie, she had the ruler like this. And then when the person said go, she just lifted it. Yeah, she just left it like that. So that's what subgroups did. So that's what you would write in number 4. Number 4 here. What are some things you can change to collect more accurate results next time? Okay? Oh, you guys broke it down already? May I look at it? Are you trying to save? Okay. Save. Okay, hold on. Can we just take a look at it first? Okay. So this is your data right here? Is this the run that you just made? Okay. Jackie, can you come over this way so we can all look at it? Okay. So what is this showing us here?
Probably just like something that's like more farther away from most of the lights.
Okay, and what is this straight line here? What is that? That didn't move. Do you see it? And then, what does this mean? Started going away, and then came back, and then going away, and then. Okay, so what in the world? What just happened? What is a possible explanation for this? Because did your car do that? It was like, beep, beep. Did your car do that? That's pretty crazy because there's no engine, huh? Oh, that's right. Oh, yes, the index card. Yeah, so the index card was flapping back and forth. But what else do you see here that could have given you such a crazy graph like that? What can you change actually to see what actually happened? Look at the axes. Can you see the axis? Jackie? Can you see the axis?
It didn't like really exactly start like close to the motion detector.
Maybe. What do you notice about the axis? Particularly the y-axis on the position time graph.
It starts from 0.9 meters.
Yeah. Okay, look. The scale is from 0.10 to 0.90. So maybe we should change the axis from like, you guys started at like right in front of the motion detector, right? You can say 0 up until like 1. And then let's see if that's different. Because sometimes like it's set it up like that and you're seeing such a tiny little window. Like from such a short little window, so it may not be so accurate. So I'm going to change the bottom to 0, and then the top to 1. Okay, when we do that, oh, it's still. Okay, so when you, either you can keep this data, or you can redo it, but when you keep this and you use this tomorrow, or like you use this in your lab report, you gotta explain what you just said. So even though it looks like our car was going back and forth, like there was a driver in there, actually it's because of the card, the index card moved flapping back and forth. Although it is kind of weird. Isn't that strange? That it says it started at 1. What is the explanation for that?
There could have been like something in the way, like about 1 meter.
So maybe it didn't even detect the index card at the very beginning, huh? But then it shows that it wasn't even moving. So that's what you've got to say. Okay. So it's okay. Whatever data you collected is whatever happened, but you've got to explain it the way you just did. That was really good. Okay. Or you can redo it. Okay. Any flaws that you noticed?
Flaws?
Yeah, like in number 4 here. Any flaws in the experimental setup? What did you say? And the next time because it was okay, so you have the error resistance. What would you do differently? I'm gonna give you all the materials and I'm gonna say you can ask me for any materials you want, okay? What would you do differently? Okay. What would you do to set up the experiment in such a way that you get better results?
I think we would fold the index card like how your student in like 5th period did it. So then it wouldn't like
the friction, like it would help. No, like the air wouldn't like make the card go back, so then I wouldn't slow the car down.
Okay. Could you use something other than an index card?
Yeah.
Can you bring your monster truck that's bigger? I know you have one at home. Can you use a different car? Yeah, if you can use anything. And I could say, bring your toys from home, whatever you want to do, as long as it fits on the ramp. Don't get too excited now. Okay. What would you do differently to get better results? But we have 2 more minutes left, so. All right. Ladies and gentlemen, give me 5, please. Thank you, Pablo. Thank you, Kiana. Thank you, Migs. And Jules, and Sierra, John, Popsicles, and many others. Okay. So, I really want to continue this conversation because many students told me in the past, when they do the lab report for this, they get so stressed out. Like, Miss Song, I set up so many. I'm like, why? It's not that hard. But I realized when you look at the graphs, because tomorrow I'm going to teach you how to import the graphs from your Vernier onto the laptop, and then have the computer generate those graphs, and you're going to make screenshots of them to import into your lab report. And you're going to have to talk about it in your lab report. So you have to feel comfortable talking about the motion graphs that your motion detector generated with your car. And actually, I think I'm going to have you redesign the lab so this group, their setup will be different from this group. Okay, and they have to be using different materials. Okay, and then you can redo it and compare your data. Okay? But the bell's gonna ring in like a few seconds, so everyone just pack up and pack up and get ready to go. The homework, just finish up the analysis questions and the conclusion questions, and then that's it. Yeah, conclusion. All the questions. Yeah, think about the homework. First analysis. Yeah, finish all the questions. All the questions. All of the questions on the pink sheet. And what else do you bring? Okay, bye-bye.